We hear a lot of talk in the media about if scientists have found life yet on other planets. But have you ever wondered what this actually means? Finding life? Allow me to bring up abiogenesis. This is the process where life forms from non-sentient matter, like rudimentary organic compounds, by eventually progressing to something more complex that can self-replicate or reproduce. Scientifically, this would have also been how the first forms of life on Earth came to be as well. So analogously, we can infer that something like this could happen on other planets in the universe, too. The key contributor to this is ultraviolet light, or UV radiation, and it's been shown experimentally that UV light might be the catalyst for building blocks of RNA, which is essential for life to form. Around other stars are specified regions called abiogenesis zones, and these are zones where the UV radiation would be strong enough around a wavelength range of 200 to 280 nanometers to initiate the photochemical processes that lead to RNA synthesis and break down chemical compounds in the atmosphere of a star, which would thus form those building blocks of life. But not too strong that it could rip apart the atmosphere, so essentially it's an exact happy medium. We can then add in the idea of a liquid water habitable zone around a star. This is where the planet is the right distance from its host star to form H2O. So, ergo, if a star is in the overlap between these two regions of the abiogenesis zone and the liquid water habitable zone, it would mean that the conditions would be super ideal for life to form. But what if the star is too quiet for any of this to happen? Like an M dwarf that doesn't usually output UV flux during its quiescent state. Enter stellar flares. Flares can give concentrated doses of UV radiation in the appropriate energy range to trigger RNA synthesis. But once again, on the flip side, energetic particles from stronger flares and CMEs can also erode a planet's ozone layer and even cause atmospheric erosion, destroying the building blocks of life and leaving the planet to be a useless rock in space. So, to find places with the potential for life to form, the best places we can look are active, low mass, and low temperature M dwarf stars that have flares to support the conditions of prebiotic chemistry, or G type stars similar to the Sun that constantly output UV radiation and have high potential for abiogenesis. If we focus our search enough, maybe one day we'll be able to confirm alien life around another star. Do you believe in aliens? Follow for more astrophysics.